Hello students, today we'll discuss the power of a lens. Now in general, what is meant by power? Power means it is a capacity or a capability to do the work, and the work of a lens is to bend the light falling on it. So therefore we can tell the power of a lens is its capacity to bend the incident light falling on it, or in other way you can tell that power of a lens power tells that to what extent lens converges or diverges the light. So in a proper sentence you can define power of a lens is the measure of convergence or divergence which a lens introduces in the light falling on it. Now if the lens bends the light more, then we can say lens is having more power. So to understand that, take an example of two convex lenses. This is applicable to concave lenses also. Take two convex lenses. Let paraxial rays are incident on both the lenses and they converge at their principal foci. So the first lens is going to converge the light rays at its focus. The second lens is also going to converge the rays at its focal length. Now compare the deviation occurred in the incident ray by both the lenses. So just compare the deviation that has occurred in incident rays by both the lenses. So this is the initial direction of the incident ray. So to this extent the ray has bent to meet the principal focus, and here in the second case it has bent by a smaller amount leaving its original direction. So looking at these two, we can tell that the lens with a shorter focal length bends the light more. Here in the first case the deviation is more by the lens which is having shorter focal length. So surely we can tell that lens with a shorter focal length has more power. Mathematically, how to define it? Power is to what extent the ray got deviated from its original direction. So for that, consider a convex lens. Consider a convex lens. This is the principal axis. A ray is incident on a lens, and this is its original direction of the incident ray. After passing through the lens, refraction by lens, it gets deviated. So this is the deviation introduced by the lens in a ray of light. So this is the deviation introduced by the lens in a ray of light. So this deviation we can call as the power of a lens. To what extent ray has got deviated is nothing but the power of a lens, or this can be measured as by what angle the ray got converge or diverge is equal to the power of a lens. But it is difficult to make a ray incident on a lens and then measure the deviation suffered by the ray. Practically it is difficult. So we have to write the equation in terms of a measurable quantity. in terms of measurable quantity. So what we'll do, we take this height as h, the height, the distance between the ray and the optic center as h, and this is the focal length. So as these two angles are the alternate angles, we can take this as delta. So we can write power is equal to delta. We can make the small angle approximation that P is equal to delta. For small angle approximation, delta can be equal to tan delta. Delta will be equal to tan delta. So your power becomes a tan of the angle of deviation. Now write the equation for tan delta. Tan is opposite upon base. H by F. H by F. What is H value? It is a distance from a ray, distance of ray from the optic center. Now what we'll do, we'll take H value as unity. H is equal to 1. So that your P is equal to 1 by F. Now why to take this H is equal to 1? Again coming back to our diagram. If you consider a convex lens, if paraxial rays are incident on it, we are considering few paraxial rays and they are converging at their principal focus. Now look at all the rays which are getting refracted through the lens. The rays at the edge of the lens bend more and nearer to the optic center of the lens bend less. So the same lens is introducing different bending effect in the rays throughout the lens. So which bending is to be considered to know the power of a lens? Because if bending is more, we can say power of a lens is more. But the same light is bending to a different extent. It is bending one ray little less, another ray little more. Now how to define the power of a lens in terms of bending of light? So what we'll do? We'll consider a standard reference, that is deviation occurred in a ray which is at a unit distance from the optic center. So what we'll do? We'll consider a ray which is at a distance of unit which is at a unit distance from the optic center. So whatever the deviation the lens introduces, whatever the convergence or divergence that a lens is going to introduce in a ray which is at a distance of unity is considered as the power of a lens. That is why we take h is equal to 1. So if you substitute h is equal to 1, P will be equal to 1 upon F. So by this equation, we can write power of a lens is equal to reciprocal of the focal length of that lens. Now this the SI unit of power is dioptra. If the focal length of a lens is 1 meter, if you substitute F is equal to 1, then the power of a lens will be 1 dioptra. If the power of a lens is positive for a converging lens and it is negative for a diverging lens. Thus, when an optician prescribes a corrective lens of power plus 2.5, so for a specs, they give you the number in terms of a power, that is plus zero point 0.5, plus 0.25, plus 2.5, plus zero point 0.6. It means accordingly you have to use the corrective lens to correct the eye defects. So if an optician prescribes a corrective lens of power plus 2.5 dioptra, means power is equal to 2.5 dioptra plus 2.5. So power is equal to 1 upon f, which gives you f is equal to 1 upon p. So 1 upon plus 2.5 gives you 0.4 meter. It means 40 centimeter. So if it is prescribed to have the lens with a power of plus 2.5, it indicates that the lens required is convex lens, because the power is positive. Convex lens of focal length 40 centimeter. If they prescribe a lens of power minus 4, if they prescribe a lens of power minus 4 dioptra, then a focal length of a lens that you have to use is 0.25 meter or 25 centimeter. A corrective lens that has to be used is a concave lens with a focal length of 25 centimeter. Now this is all about a power of a lens. So after studying this in detail, now you can define the power of a lens as, power of a lens is defined as the tangent of the angle, tan of the angle, tangent of the angle by which it converges or diverges a beam of light falling at unit distance from the optic center. So this may be asked, the definition may be asked for 1 centimeter, or mainly the unit of the power of a lens is frequently asked for 1 mark.